On the bottom of page 1, in the notes here for 6.5, it starts with a try on your own problem. So before you do that, take a moment to make sure you've caught up from the previous video. Copy the notes, see if there's any questions you have, make a note of those, try to tell somebody, take a moment to tell somebody, or at least talk it out loud for yourself, what you've seen, so that you can start to establish these items into long-term memory. And notice as you do these try problems, sometimes I'll throw in one where it really helps if you start by asking the question, what's different? What's different about this one, number 48? So I'll leave you with that. You'll want to pause the video, ask yourself what's different, try to come up with the answer using either definition or rule of exponents when you're dividing polynomials. That's the topic of this section, and we'll come back with the answer in just a moment. So what is different about this problem? Well, the y exponents are the same top and bottom. Now, does that change how we do it? No, we're still going to take the y with the top exponent minus the bottom exponent as our answer. In this case, though, when you get y to the 2 that's on the top minus the 2 that's on the bottom, you get y to the 0, and that's going to equal 1. When you think of it in terms of definition, y squared is y times y on the top, y squared is y times y on the bottom. Both of those cancel, and that's just as if you'd left 1, and that's just in terms of the y's here, okay? So that's what happens with that. When you do the entire problem, the answer that you should get for this one is negative 1/3. Pardon me as my pen is deciding to run out of ink here. See if I can revive it. Nice. Negative 1/3 x to the 14th. That's what you should get if you tried that question on your own. Now, what if you had the dividing polynomials inside the parentheses here, negative 2a to the 8th over b cubed, and then you raise that to another power. This is actually number 34 from page 382. And what we'd look at is, here's the instructions. It says simplify each expression using the quotients to powers rule. If possible, evaluate exponential expressions. So again, as they walk you through this section, you're going to realize that there's a lot of rules to memorize. And if that seems like a daunting task to you, then what you want to do is, again, use the definition. So if you have something like this, where you have something raised to an exponent, just imagine that entire something multiplied by itself 5 times. So let's rewrite that down here. If we had negative 2 a to the 8th raised to the 5th over b cubed to the 5th. In fact, that is the rule. The 5 applies to the top and the bottom. The exponent applies to the top and the bottom. Then what you have is negative 2 a to the 8th times itself 5 times. Negative 2 a to the 8th, the top, times itself 5 times. And then you have the bottom, b cubed to the 5th, times itself 5 times. Which would make sense because, by definition, if we don't remember the rule that the 5 applies to the top and to the bottom, you would just take this entire thing and multiply it by itself 5 times. Here you see the first one, second one, third one, fourth one, fifth one. It's all there. We just happen to separate the tops and the bottoms. And then what does that mean? Well, you would then have, on the top, you could rearrange this using our Math 60 properties here of the commutative property, the associative property. We can rearrange all this because it's all multiplication. It's really negative 2 times itself 5 times. And it's a to the 8th times itself 5 times. On the bottom, it's b cubed times itself 5 times. It's how many of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But we remember, oh yeah, 15. Where does the 15 come from? 3 times 5. So you would get b to the 15th on the bottom. On the top, negative 2 to the 5th would become negative 32. A to the 8th raised to the 5th. Imagine you've got 8, another 8, another 8, another 8, another 8. There's going to be 8 plus 8 plus 8 plus 8 plus 8. Another way to say that is 8 times 5. That's how many A's you're going to have. That's A to the 40th. So the rule here that we're discovering, so our final answer is negative 32 A to the 40th over b to the 15th. Hopefully that's a little easier to see now. Negative 32 a to the 40th over b to the 15th. The rule here that we're noticing is that when you have a power raised to another power, even if you've got division or other things going on here, when you raise a division to a power, that power applies to both the numerator and the denominator. So the power applies to the whole numerator, not just the algebra part of it, but it applied to the number part as well, and to the negative. And it applies to the whole denominator as well. In this case, there was just b cubed, so it was b cubed to the 5th, which is b to the 15th, because it's 3 times 5. Okay, so the power applies to the whole numerator and it applies to the whole denominator.